Okay, so differentiation and displacement, velocity and acceleration. So we're looking at the relationship between a displacement over time graph, a velocity over time graph, and an acceleration over time graph. Now this function here is a cubic function. Now I'm just going to create a cubic function out of my head here. It's not exactly going to match up, but it'll do for now. Let's call it 2x cubed plus 4x squared plus 7x minus 9. So that's a cubic function, a leading power of 3, 2, 1, and 0. Now this function here, now this is the velocity function of this displacement function. So if this was the displacement of an object over time, this is the velocity of that object over time. Now, with a little bit of practice, you'll be able to look at this displacement graph and immediately tell me that the equation of this velocity graph is 6x squared plus 8x plus 7. Those are related. Now, as I move from this function to this function, remember, this was our displacement function, this is our velocity function. What I'm doing is a process called differentiation, and this is called the derivative. This is the derivative of that function. We show that by putting a little f dash in here. So if this was the function f of x, this is the function f dash of x, and you can say it just like that, f dash of x. Now, as I move through these graphs, I can differentiate the derivative of this function a second time. If I do that, it's going to be f double dash, f dash dash of x. So it's going to be 12x plus 8. So I've got a cubic up here, I've got a quadratic here, and then I've got a linear equation here. And the process that we're moving through is differentiation. I differentiate this function to turn it into this function. I differentiate this function to turn it into this function. So the rule that I'm following here, if you take a look, I'll talk about it in words first because you really need to be able to do this without using a formula. I'm taking this number and multiplying it by, this number and putting it out the front. So my coefficient becomes 2 times 3, which is 6. And then I'm taking this number and I'm subtracting 1 from it. So 3 becomes 2 minus 1. So if I ask what's the derivative of 4x squared, you'll take 2 and multiply it by 4, and that becomes 8. And you'll take 2, the power of 2, subtract 1, and it becomes 8x to the power of 1, which is just 8x. Now, here, where you see 7x, we can go through the same process, because that's still 7x to the power of 1. 1 times 7 is 7. We decrease the power of x to 0, x to the power of 0. X to the power of 0 just becomes 1, so that ends up being 7 times 1. Now, you shouldn't go through that weird process. Anytime you see 7x, if you're finding the derivative of 7x, you should immediately just say, oh, just get rid of the x. It's just 7. So the process again, 6x squared. I'm taking the 2 and I'm multiplying it by 6, and that's giving me 12. And I'm decreasing that 2 to the power of 1. So it's x to the power of 1. This one here, 8x. As soon as I see 8x, just x to the power of 1, we end up with just 8, full stop. Now, I'll write up the formula so you can see what it looks like. Alright, so the rule is very, very simple. If I'm trying to differentiate something, it's ax to the n. If that's f of x, ax to the n, then f dash of x is an to the x n minus 1. So, very quick example here. F of x equals 7x to the 6. That's going to be equal to 7 times 6, so AN, that's 7 times 6, x to the 6 minus 1. Now you're going to be doing so many of these that if you're writing it out like this, just don't. 7 times 6, 42, x, 6 minus 1, 5. So every one of us should be able to go direct from here to here, not using this formula, but here is the formal formula that you might want to write down and make sure that you're using it. This is how we'll go from this kind of function, a displacement function, to a velocity function, to an acceleration function, because we're going to be able to move, we're going to want to be able to move from one to the other.